Hello everyone. So in the series of the big data video lectures, today we will be seeing the introduction to the regression and what are the types of regression. So we'll start with the basic introduction of regression. So as we have seen in the previous videos, regression is used to find out the relationship among the two variables. So it is a predictive modeling technique to find out or to predict how is the relationship among the two variables or more variables. That is where independent and dependent variable, which is the dependent variable, which are the independent variable, and how they are interrelated to each other. Okay. So generally it is used for the prediction and the causal inference. Causal inference in the sense to find out the relationship. Inference in the sense how they are related to each other. So regression is basically used as a classification technique, or it is basically it is used for finding out the relationship whenever we are relating any two variables. As we can say, for example, we want to find out the sale of bread and butter. So we can use regression here, how the sale of bread is affecting on the sale of butter. So to find out this, we can use regression. So there are basically two types of regression, that is single and multiple regression. So as the figure indicates, is simple in the sense there are only two variables, whereas in multiple there are multiple variables. So feature here it will be a single feature, whereas here more than two features will be found among the variables. Okay, so here single explanatory variable, one will be dependent and other will be independent variable, where here there are include many number of explanatory variables. One will be the independent variable and there will be multiple dependent variable among that among the other variable. Okay, so the regression is of two types, that is the linear regression and non-linear. So in this both simple and multiple, again we have further two types, that is linear regression and non-linear regression. Okay, so this is the expression to find out the regression, that is y is equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus dash 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 beta n xn plus what is this? So this is a random error. Okay, so each term is explained here. So y is the dependent variable and there are multiple independent variables among the expression. So beta is the coefficient of regression, or coefficient which is used before the independent variables, and these are the explanatory, that is this is dependent variables, and this is the random error. Okay, so what is this beta? Beta is a value that is computed by the regression tool, reflecting the dependent variable relationship, how it is related to the dependent variable. And this residual is the error or the portion of the dependent variable that isn't explained by the model. The model is under or over prediction. So this is the expression of simple multiple linear regression, where there are number of independent variable and a single dependent variable. So how is the analysis is done? So as I told you, linear and non-linear. So in the linear there will be a straight line relationship. Okay, the line will be straight line relationship. In the linear relationship it will be a straight line, and the line will be in the form of y is equal to mx plus b. So y is the dependent variable, m is the weight, x is the independent variable, and b is the error associated with it. So non-linear implies the curved relationship, that is it will not be a straight line. So as we can see here, this is a linear but positive relationship. So again there are further types, that is positive, negative and no. So positive in the sense this line is growing in the forward direction, so it is a strong positive relationship, whereas here the line is coming downwards, so it is a strong negative relationship, whereas here the line is not at all denoting as a forwardness or a backwardness, so there is no relationship among the variables. Okay, so these are the types of regression. So previously what we seen, what is the regression, what are the basic types of regression, that is simple and multiple regression. So each one we will see again further, how is the multiple regression calculated, how is the simple regression calculated. So what is positive relationship, negative relationship. So these are the types of regression. So each regression is used in the machine learning algorithm. They has a specific term associated with each of this regression. So we'll be seeing in the further videos. So what are the types of regression? Linear regression, polynomial regression, support vector regression, decision tree regression, random forest regression, ridged regression, lasso regression, and logistic regression. These are some of the regression types that are used in the machine learning for analysis to find out the relationship among the variables.
So as you can see in the today's video, we will be seeing the classification of linear regression, or what is linear regression. So regression is of two types, that is linear and logistic regression. So in the next video we will be seeing what is meant by logistic regression. The basic introduction of regression is already in the description box, you can go through it. So in linear there are two types, that is simple and multiple, as I told you before also. So in the how are the equations of simple and multiple equation, how we can solve it and how they are related to a specific variable, we will see in this video. So in the regression, mostly it is preferred when the variable is in the form of numeric. So when the data or the dependent variable is numeric, we use the regression for analysis. So this is the most important thing to remember when we go with regression. So regression is a very important concept when we are dealing with machine learning. So regression is find out to use or evaluated to calculate the relationship among the two variables, that is dependent variable and independent variable. So what are these variables and how we can find out the relationship, we will see in detail. In this video we will see what is meant by linear regression. The introduction video to regression is already on my channel. The link to that video will be in the description box. Go through it. So in the today's video we will see what is meant by linear regression and what are different types of linear regression. So let us start the video. If you are new to my channel, don't forget to subscribe my channel. So whenever we have a linear relationship among the variable, then we will use the linear regression. Like here x is the one of the variable and y is one of the variable. So if they have a plot like this, then we can call it as a linear regression, where increase in x is also causing increase in y. Then such type of relationship is called as a linear regression or linear relationship. So here whenever we deal, so here x is the independent variable and y is the dependent variable. So when in linear regression there are two types. First one is simple linear regression, and the second one is multiple linear regression. So these are the two types in linear regression. First is simple linear regression and another one is multiple linear regression. In simple linear regression, the variables are of two types. Means there is a one dependent variable and one independent variable. So in linear regression there are one dependent variable and one independent variable. But in multiple linear regression there is a one dependent variable but there are multiple independent variables. So how these equations are carried out, we will see now. So the equations for linear and multiple are as follows. So here is simple and here is multiple linear regression. So for simple linear regression, y is equal to alpha 0 plus alpha 1 x1, where here it is y is equal to alpha 0 plus alpha 1 x1 plus alpha 2 x2 plus dash 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 alpha n xn. So this is the equation for simple linear regression and multiple linear regression. So how we got this? What is alpha? What is x? So here x is the independent variable and y is the dependent variable. So similarly, in case of multiple linear regression, y is the dependent variable and x1, x2, xn are the independent variables. So here there are multiple independent variables, whereas in simple regression there is a single independent variable. So what is alpha? So alpha is the regression coefficient. So in the further videos we will see how to find out the regression coefficient. So here alpha is the regression coefficient, same as here. So this equation can be normalized as y is equal to c plus mx. So here x is the independent variable, y is the dependent variable and c is the constant, whereas m is the slope. As we have shown the graph, when it is a simple linear regression, the graph will be straight. Whenever we plot x and y in simple linear regression, the graph will be straight. So the slope is the slope of this straight line. Okay, so this is the simple linear regression. Similarly, in multiple linear regression, x1 comma x2 dash 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 xn are the independent variables and y is the dependent variable. Similarly, alpha is the regression coefficient. Regression coefficient. So how to find out the regression coefficient we will be seeing in the further videos. So here whenever we relate that how is the regression or how is the relationship between the variables can be done by using this equation. For simple linear regression this equation is used, whereas for multiple this is the equation to find out the multiple linear regression. So here is one of the equation where it is a multiple regression equation. So here we can see y is the value given as 0.2 plus 1x1 plus 3x2 plus 5x3 plus 0.4x4. So these are alpha 0, alpha 1, alpha 2, alpha 3 and alpha 4. So here there are how many independent variables? We can find out easily. Okay, so we can see here are 4 independent variables, that is x1, x2, x3 and x4, and the dependent variable is single, that is y, and there are 1, 2, 3, 4, 5 regression coefficient. So if we want to find out which is more related or which will provide us the better result whenever we are finding out the regression. So here finding regression means I have a 4 parameter. Consider the example, I am finding out the brighter student. For that I am taking the 4 parameter. First parameter is attendance of the student. Second parameter is the past mark history of the student. Third parameter is the behavior of the student. And the fourth parameter is the academic record of the student. So we can see that here for the third, like for alpha 0, 1, 2, 3. For alpha 3 the value is 5. So it is the greater value among all those things. So we have considered alpha x3 as a academics. Okay, academics of specific student. So this is the best parameter to find out the regression among all those variables, since the value of alpha 0, alpha 1, alpha 2, alpha 3. Alpha 3 is 5, which is greater among all those. So this is the best parameter to find out the regression with respect to y. So we can go with alpha 0, 1, 2, 3. Alpha 3 which is equal to 5. So alpha 3 is greater as compared to alpha 2. Also alpha 3 is greater to alpha 4. So if we consider among all of the values of alpha 3 is much greater. So we will take alpha as a parameter to calculate the regression, and so alpha is the best regression coefficient to find out the relationship among the variables. Okay.
Hello friends, welcome to Big Data Knowledge Hunt. Today we will be seeing the topic which we have started previously, that is the regression. In the previous videos we have already seen what is regression. Link to that video I will be providing in the description box as well as I section. So today we will be seeing the linear regression in brief, how to calculate. So we have shown what is different types of linear regression, that is simple and multiple. So today we will be seeing the simple linear regression and how to calculate it. So whenever we are dealing with regression, we have to notice that it is only used for numeric variables. So whenever we have numeric variables, we go for regression. And the next important thing is that we will deal here with two variables. So the first one will be the dependent variable and the another one is the independent variable. So we have to deal with these two variables in the simple linear regression. So today we will be seeing one of the example how to evaluate the regression coefficient. What are the different formulas that we have to deal with whenever we are calculating the simple linear regression. So the basic formula is y is equal to a plus bx. So here b is the slope of the line and a is the intercept. So if we see in a graphical format, how we can show it, as we can draw the simple linear regression as a straight line graph. So in the straight line we can plot the points based on the straight line distribution. So this straight line is known as the slope and the point that intersects with the y-axis is known as the intercept. So that is the slope of a line. So we have to calculate these things. So how we will get the b, how we will get the a, we will see in the further slides. So how to calculate this? So this is a simple linear regression formula. So y is equal to a plus bx. This equation is used to find out the simple linear regression. So the different formulas that we need to calculate whenever we are calculating the simple regression are y is equal to a plus bx. That is the formula that we saw previously. Next, b is the slope. So the slope b to the regression line can be calculated as b is equal to r standard deviation of y divided by standard deviation of x. So r is the correlation coefficient, that is Pearson correlation coefficient, and standard deviation of y and standard deviation of x. So here how to calculate the r, we have already shown the correlation coefficient. So link to that video I will be providing in the description. You can go through it and calculate the r. Next is the intercept of line or a, that is the regression line, that is a is equal to y bar minus bx bar. So y bar and x bar are the mean values and r is the regression correlation coefficient. So the formula for correlation coefficient r is summation of x in bracket x minus x bar into y minus y bar divided by square root of summation of x minus x bar into summation of y minus y bar whole square. So how to calculate r? A numerical example already I have demonstrated. Link to that I will be providing. So you can easily calculate the correlation coefficient and then you can calculate the standard deviation of x and standard deviation of y. So the formula for standard deviation of y is square root of y minus y bar whole square divided by n minus 1. So n is the total number of variables entry. So if we consider an example, there are 6 x variables and 6 y variables. So the value of n will be 6. Similarly, we can calculate standard deviation of x, square root of x minus x bar divided by n minus 1. So we can calculate the standard deviation of y, standard deviation of x and r, and then we can put it into value and get the value of p. Similarly, we can calculate the value of a. So here y bar and x bar are the means. Now if we consider the case as simple linear regression but multiple variables, that is multivariate analysis. Like if we want to predict the price of any house, so
So we can predict the price based on different factor as the area of the house. Next is the how is the price of that area or the land price, and next is the age or how old that house is. So based on these three factors we can predict the price. So here there are three variables, that is we have here x, y and z. If we consider these three as the variables and p is the price that we are predicting. So here p is the dependent variable and x, y and z, these three are the independent variables. So we want to predict the price of a dependent variable based on these three independent variables. So how we can find out it? So if we are using one-to-one binding, then we can use simple linear regression formula. But here we have three independent variables. So how we will find out the price of the house based on the three variables is we can go with the formula. So here I will note down the formula for the multivariate analysis, that is simple linear regression but with multiple variables. So the formula is as below. So we have shown previously that the formula for the simple linear regression is basically y is equal to a plus bx, where we have a single independent variable x. But for multiple it is y is equal to a plus b1 x1 plus b2 x2 plus b3 x3 and so on. So if we have three variables, we can write it as b1 x1, b2 x2 and b3 x3. So b is not the slope. So here b is the coefficient of that specific independent variable, and a is the intercept of that line. So here we cannot represent a single line, a straight line, since we have a multiple independent variables. So these are the two different formulas when we deal with the regression, that is simple linear regression and multiple linear regression, that is multivariate regression. So I hope you are clear with the idea how to calculate the simple linear regression. So till now we have saw the categorization of linear regression as simple and multiple. So in these types we have seen what is simple linear regression, what is multiple linear regression, and we have seen the different formulas used to calculate. So multiple is also called as multivariate linear regression. So the formula for simple is y is equal to a plus bx, and for multiple it is y is equal to a plus bx1 plus bx2 plus bx3 and so on. So this was the basic categorization of whatever we have learned till now. So in the next series we will see one numerical example. So for more such videos, stay tuned. Don't forget to subscribe my channel and make sure you press the bell icon. Thank you for watching the video. If you are new to my channel, don't forget to subscribe it. In the today's video we will be seeing a numerical based on the linear regression which follows the equation y is equal to mx plus b. So previously we have seen what is mean by regression and what are the different types of regression and what are the different formulas. So link to that will be in the description, you can go through it. So in this video we will see a numerical where we have x and y values, and these are the formula that are used to evaluate the values, where m is the slope and b is the intercept. So this is the formula for m, and for b we have two formulas for b. So we can use any one of them. There are many formulas where we use standard deviation also. We have shown already in the previous videos. So now for x and y values we have to calculate x, y and x square, since we need that in a formula. So the xy will be 2, 1 and 6, and the x square will be 4, 1 and 9. Now we will take the summation of all of these terms. So the summation of x will be obviously 2, summation of y will be 2, and summation of xy will be 9, and the summation of x square will be 14. So these are the summations. Now we have the values and we have the formula. So we will put the values into the formula. So the formula for m is n into summation xy. So n is the total number of values. We have 3 records. So 3 into 9 minus summation x into summation y, which is 2 into 2, that is 4. Similarly downside n into summation of x square, so which is 14, 3 into 14 minus summation x whole square. So summation x is 2, 2 square is 4. So now we will do the calculation. As we know, 9 3s are 27 minus 4, and downside we will get 42 minus 4. So after solving this, we get the value of m as m is equal to 23 divided by 38, which is approximately in 0.605. So this is the value of m that we get from the numerical. So this is the slope, which is the m value. Now we can calculate the value of b by using two formulas. So already we have calculated the m, so we will use the downside formula for the calculation. So we have summation of y is 2 minus value of m is 0.605 into value of summation x is 2 divided by total number of values. Here n is equal to 3, so we will put n value as 3. After solving this equation, we will get the value of b, and then we can put it into the equation, that is y is equal to mx plus b. So the value of b will get is 0.26. So the value of equation is y is equal to mx plus b. So we have the value of m, that is 0.605 x plus the value of b is 0.26. So this is the linear regression equation for the given set of values, that is x and y. So whenever the points are given, we have to use the formula and calculate the values so that we can find the linear regression equation line. So here the 0.26 values denote the b, that is the intercept, whereas 0.265 is m, the slope of the line, and x is the independent variable, whereas y is the dependent variable. So for more such videos, stay tuned and connected. Also follow me on Instagram and don't forget to channel for more videos. Thank you.
Hello everyone, welcome to Big Data Knowledge Hunt. In the today's video, we will be seeing the linear regression line finding out by using a Excel. So in the Excel, we will find out how to calculate regression line, how to calculate the regression coefficient, that is R. So let us start with the tutorial. So if you are new to my channel, don't forget to subscribe it and press the bell icon for more updates related to new videos. So in the previous video, there are on my channel where we have discussed what is meant by regression and what are the different types of regression. The link to that will be provided in the description box. You can go through it. So here I have taken two variables, that is x and y. So here y is the dependent variable, whereas x is the independent variable, and we have to find out the line of linear regression. So as we all know, the equation for line of linear regression is y is equal to mx plus b, where m is the slope of the line, x is the independent variable, y is the dependent variable, and b is the intercept, where the line intercept the y-axis. So this is the equation of line. So we have to find out this equation. So how to find out it in a Excel? So let us start. So here I will select the points for which I have to plot the graph. So first I will plot the points and then we will see the linear regression. So to point the graph or to plot the graph, we will plot the x and y point. So I am selecting this point, pressing the shift and then the last point. So these are the selected points for which I have to plot the graph. So then we will go into the insert and then we will plot a scatter plot. So you have to choose which type of plot you want. So I am choosing this. So you will get a plot for this. So we are getting the different points that we have in the given set, like -2, 2, next is 1, 2. So this is the plot for the given line of regression. So here we can't draw a line of regression properly because the points are very scattered. So we will see whether it is possible to get a linear plot or whether it is what will be the line of regression for this particular point. So here you can also provide the names for the x and y axis. To provide the name, you have to go to layout and then in the axis title you can provide the title. So for primary horizontal, I will provide the title as value of x. So I will provide it as x values. Similarly, again I will go on the layout and then select axis title. For vertical axis, I will provide a rotated title as y values. So we have created the plot for x and y values. Now we will create the linear regression for that. So here only in the layout we have option trend line. You can go to more trend line option. Here you can see the different options that are present. Whichever option you want to choose, you can choose. Now here we want to choose a linear regression. So we will go to more trend line option and we'll select the regression linear itself. Here we'll display the equation on the chart. So if you close, you can see, so this is the equation for the linear regression. So as you can see, the equation is y is equal to 0.512x plus 1.159. So here m is 0.512 and the value of b is 1.159. So this was the simple example where using Excel you can create the linear regression line. So this you can solve by using formulas. We have different formulas. So if you solve the same numerical by using formula also, you will get the same output. So I hope everyone is clear with how to calculate the linear regression or how to calculate the line of regression in Excel. So thank you for watching the videos, and for more such videos related to the concept of statistics, machine learning and big data, stay tuned to my channel. Thank you.